One of the things that you have to do a lot with fractions is simplify them. We've already talked about simplifying expressions, which is taking something that's a bit complex, manipulating it, changing it a bit, to give you something that looks simpler, something that's efficient, something that I always describe as means the same thing with writing the fewest amount of strokes with my pen. So that's what we're going to do with fractions as well. And I'm going to start by having you draw again. We're going to draw the fraction 3/6. Okay? So we're going to draw this. So I'm going to draw my circle. And you draw this. I'm going to split it like this and then cut it in half kind of like that and cut it in half kind of like that. So that should get me something broken into sixths. And then I'm going to shade in 3 of them. 1 and 2 and 3. So this is the fraction 3/6. Okay. So one thing that you should notice, right? We always just ask, what do you notice? Is that this fraction 3/6 could be thought of in a slightly different way. We could take this exact same circle and break it up into equal slices a different way. Remember, fractions, we're always having to deal with equal sections, equal sized pieces. So if I take my blue marker and highlight it like that, outline it, what I see is I have this section over here, which is all shaded in, and this section over here, which none is shaded in. And because the slices are equal, I can really look at it like this. Two sections, one entire section is shaded, which means 3/6 is also equal to, or we say equivalent to, 1/2. 3/6 is equal to 1/2. Remember, an equal sign, as we talked about before, means the things on both sides mean the same thing. 3/6 and 1/2 are equal. We could write it the other way. 1/2 and 3/6 are equal. So, a lot of cool things happen with fractions when we have a statement of equivalence. We call it a proportion. One thing that happens is, and you might have seen this before, if you, again, this only works with fractions that are equal, if you multiply, we call them cross products. If you multiply diagonally, you should get the same number. 6 times 1, 2 times 3, they both equal 6. You should be able to take the same operation, multiplication or division, to the other side and get that answer. So from 3 to 1, we would divide by 3. From 6 to 2, we would divide by 3. So if fractions are equal, this will be the same multiplication or division operation. What about this? 1 to 3. What do? We multiply by 3. 2 to get to 6. We multiply by 3. Right? As long as those are the same, multiplying or dividing, those fractions are equal to each other. Okay, so that's just a little information about fraction equivalence. What we're going to be doing is simplifying our fraction. So I'm going to give you a fraction that needs to be simplified. And the reason I say the word simplify instead of the word reduce is because reduce makes it sound like it's getting smaller. But did 3/6 get any smaller when we changed it to 1/2? No. It was just written with smaller numbers. What matters in a fraction, this is the most important thing. What matters in a fraction is the relationship between the two numbers. The relationship between 3 and 6 is the same as it is between 1 and 2. The bottom number is twice as big as the top number. It doesn't matter how big the numbers are individually, it matters how they compare to each other. So we're going to take 4/6 and reduce it. I'm going to teach you a way you've probably never seen to reduce a fraction. What you've probably always done, I'm guessing, is this. And you can still keep doing it. I'm just going to give you a better way, I think. You've probably always said, well, what goes into both 4 and 6? And you've done something like divide by 2, divide by 2, and then you get 2 and 3. And then you might be thinking, is that done? Can I go any further? And in this case, it is done, right? You can't go anymore. But the problem comes in when you wonder, am I done? Have I reduced it all the way? So that's why I'm going to show you a new way. And I really, really encourage you to try this because this is going to carry you all the way through this class and into things we do in the very, very last conversations in Math 40. Right? The end of beginning algebra is still using this specific concept that we're going to do right now. And it has to do with something we've already done. Do you remember prime factorizations? We talked about those recently, prime factorizations. So if I do the number 4, if I take the number 4 and do its prime factorization, remember a little factor tree, it would be 2 times 2. 4 is equal to 2 times 2. And 6, if I do a factor tree and write its prime factorization, it would be 2 times 3. Simplifying fractions, I'm going to write this down, this is important. Simplifying fractions really means removing or canceling common factors. Ooh, there's that word again. Oops. Common factors. Simplifying fractions means removing or canceling common factors. Factors are things that are being multiplied. See this? Multiplication, multiplication. As long as things are being multiplied, they have to be being multiplied. And there's the thing on top and thing on the bottom that match up. We can cancel them. And it's doing the same thing that we did here, dividing by 2. And what's left over, the 2 over the 3, right, as long as those can't be reduced anymore, that's always going to be your reduced fraction. Let's try it with a little more complex one. So I want you to pause the video and try this. Simplify 16 over 28. Pause the video, try it using prime factorizations. I'm going to keep going. So I rewrite my fraction. I do a factor tree. I'm not going to show it all anymore. A factor tree for the number 16 gives you this prime factorization. 2 times 2 times 2 times 2. They're all prime numbers, and it's all multiplication. For the number 28, it would be 4 times 7, and 4 is 2 times 2. So I'm going to do these mentally. You might still need to write them out. They're all prime numbers. They're written as multiplication. Now I look to see what I can cancel. Well, there's a 2 on top and a 2 on bottom. They can cancel. There's a 2 on top and a 2 on bottom. They can cancel. Nothing else can cancel. That's it. So what we do is we put the things back together. We multiply 2 times 2, which is 4. And the only thing left on the bottom is 7. So 16/28 equals 4/7. You don't have to wonder if you're done. You don't have to wonder if you missed anything. As long as you do prime factorizations and cancel, you're always going to end up with the correct reduced fraction. Let's try a couple now that have variables in them. So let's try 3x over 4xy. Pause the video. Try it. I'm going to keep going. So I think about what the prime factorization would look like. Well, 3x would be 3 times x. That's it. Remember, what is x? X is just a number, right? X is just a number. We don't know what it is. 4 would be 2 times 2, and then we have times x, which is just a variable, a number, and then times y, which is a different number, maybe. It doesn't have to be, but it could be. What we do know is that I don't have any numbers on top and bottom that match up. But I do have this, the variable. And remember, the variable can be any number in this case. They could both be 3s or 5s or 7s or 12s or 100s. It doesn't matter. But what does matter is that they are the same. And canceling common factors is how we simplify. So we just cancel those x's, one on top, one on bottom. And we put together everything that was left. There's a 3 on top, and 2 times y on the bottom. 3 over 4y. That is our simplified fraction. And then we've got one more. Let's do one more. So we have 18 x squared over 30x. Pause the video, give it a shot. Again, I'm just going to keep going. Factor tree, 18. 18 would be 2 times 3 times 3. And x squared, if I'm writing it as prime factorizations, would be times x times x. We think about what does x squared mean? It means some number, I don't know what it is, but it's times itself. On the bottom, 30x would be 2 times 3 times 5, then times x. So pause and stare at this. If you're all confused, stare at this. Go back and listen to it again. Then we look to see what they have in common. So it's all multiplication, it's all prime numbers. Now I can remove common factors. I can remove 2's, I can remove 3's, and I can also remove an x from the top and an x from the bottom because they're the same number. I just don't know which number. Now I put it all back together. What do we have left on top? Here's where a little circle or a little highlighter might help. So what do we have left? 3 and x are on the top and a 5's on the bottom. So that means it's 3 times x over 5. This fraction over here simplifies to that. And that is how we can reduce fractions. Simplifying fractions. Prime factorizations cancel the common